Kenya's biggest conversation. Thank you very much for choosing the Situation Room right here on Spice FM. We are in Nairobi. We are in Mombasa, Kisumu, Nakuru, Eldoret, Nyeri, Malindi. We broadcast worldwide via live streams, www.spicefm.co.ke. Also, we live stream on social media handles, Spice FM KE, Facebook, Twitter, as well as YouTube. In the studio on the hot seat. Now, this is not going to be a hot one today because we want to learn. So, is Dr. Masika, who's a virologist, and we've already said karibu and welcome. Now, let's start straight up. Who is a virologist? You know, some people of a certain age know the other virologists. Some men of certain age start interacting more with the other virologists.
Observe where his eyes are focused on.
And I'm actually looking at
when he's making
it's because I can't look at myself.
Age.
You can't what now?
I can't lock at myself. You know, so I just have to look. You know, you happen to be in front of me.
At the next best option.
Next.
Yeah, I'm glad to be in the Situation Room today, and thanks for cooling down the seat for me. A virologist really is somebody who studies viruses. After studying them, of course, you're expected to teach others and find solutions for them, like drugs, vaccines, treatments. But the basic definition is you study viruses.
You understand the virus.
What I do on most of my days is research at the University of Nairobi and teaching. So I teach medical students and others about viruses. And we study viruses for different reasons, testing new vaccines, testing new drugs, and also for understanding how viruses infect the body, what they do when they infect the body, how we can control them, how we can inactivate them, and things like that.
How do they come about?
Viruses are many. In fact, if you were to weigh all life on Earth, viruses weigh more than anything else combined.
They're more than us.
Yes. So they are a legion, so to speak. There are so many of them. Thankfully, only a handful. I mean, if you compare with the numbers, infect humans, because viruses are very specific with the things they infect. Some will actually just infect trees, others specific animals. Some only humans, like measles, doesn't infect anything else. But some are a bit more promiscuous, so to speak.
Democratic.
They will cut across several host ranges, and coronaviruses are one of such that is able to infect bats, whales, snakes, pangolins, birds, humans, and even other animals. So the viruses are very interesting creatures indeed.
So this coronavirus, and you said the coronaviruses, how many are they, and what is corona?
Coronaviruses is a family. There are about 40 of them. And in this 40, we know there are about 4 that have been causing common colds, a quarter of common colds. We call them human coronaviruses. And there are 3 others that have emerged in the last 20 years, including this one, that now have crossed over from bats through other species to animals. And you may recall in the early 2000s, we had SARS. This is now called SARS version 2. Because they're very closely related. In 2012, we had MERS, which is Middle East Respiratory Syndrome coronavirus. So these 7 viruses are the ones that have been shown to infect humans. The other 30-something infect other mammals and animals.
They haven't crossed over yet.
Yeah, and that's a very good something to note, because viruses are capable of crossing or jumping species after mutations. And that is what happened with the current this current COVID-19, and that happens because of our interactions with animals. So when you get exposed, the virus initial infection could abort because this is a new species. But with re-exposures and constant mutations that viruses undergo, you eventually get a strain that is capable of infecting humans. And what they do is, by changing the surface, the corona thing has the spikes that make it look like a crown.
Yeah.
Those spikes are like keys. They are the keys that it uses to enter your cells. And for different viruses, those keys are very specific to different cells. And if sometimes that is changed through mutations, and by chance it's able to attach to new cells, that could now cause something like we're seeing today. Yes.
Okay. We know that, from what we've seen, you talked about the human cold, the common cold that we see, the flu, etc. Yes. Present symptoms Now, in this case with corona, we've seen that very many cases don't present any symptoms at all, and then people still find themselves to be infected. How then does that work? Where in some cases you would find, others you don't find, same virus.
This is very common with viruses, that many times you have what we call subclinical or asymptomatic infections, where somebody is not showing any signs, yet they are infected. It's common with many infections, and especially viruses. Even with common colds, you could have be infected with a common cold virus. If we swab your nose or your throat, we find it, but you're not showing any symptoms. And depends with several things. The strain of the virus that is infected you, how virulent is it, how strong is it, the immune status of that person, the dose of that person, the environment that the infection is occurring. So if you look at how infections present, there are really different things that will determine how each individual deals with them. And for this, we've seen that for most people who get infected with COVID-19, up to 8 in 10 will have mild to moderate disease. That means they may have fever, they may have a cough, some may have tiredness or exhaustion, feeling of exhaustion. And a few, maybe the rest, the 2 out of 10, may start getting difficult in breathing. And that's the people who might need hospitalization, oxygen therapy, and things like that. So it is, yes, possible to get people who are symptomatic. And that's actually one of the problems you have to deal with, because you don't know when somebody is not symptomatic. You don't know how to detect that. Yes.
So the one that we've seen now, this coronavirus that's been called COVID-19.
Yes.
You're saying that the possibility is that it came from animal to human. That's what is being said.
Yes.
Is there anything that you as virologists are able to see? This is the evidence that this one has jumped from this animal, and this is a particular animal it's come from.
Yes. So what we do is with viruses, you get the genome. The genome is like a fingerprint, and you can see closely. The same way I can analyze your child and see this came from you. You can look at a virus and see the similarity in the genome. And what we've seen with the current COVID-19 is that there was very close similarity with a bat strain, but even closer similarity with a pangolin. A pangolin is an interesting looking animal that looks like an armadillo. It's very funny shape. But the most interesting about it is that it's trafficked across the world a lot. And that causes a lot of opportunity for interacting with humans. So there's about 96% similarity with a pangolin strain of this virus. It could be that a few days from today, we find an even closer match. So this is a developing issue. I remember in 2002, and this I read from history because back then I didn't know exactly what a virus was. The initial blame was laid on some animals called civet cats, but later it was then placed squarely on bats. So we have more information coming in all the time, and by comparing the genome sequence, you can even time it. It's like a molecular clock, and time that this actually emerged in this year or this month. Depending on how many of the viruses you have, because depending on the number of mutations, you can time it backwards. Yes.
People have said that some of the cases that have been reported now across the world don't have any connection to China.
That's a very good point, a very important point. That even though we are talking about an animal link, actually, a lot of the cases are human-to-human transmission. The origin may have been an animal, but right now, the driver of this outbreak is man-to-man, man-to-woman, woman-to-man transmission. And you can see even in Africa, most of our cases have come from Europe and other parts of the West. The outbreak in China is dying off. Now they are reporting less than 10 cases in a day. Previously it was thousands. And that's because of the very strong measures they took despite the high numbers. So the driver of the epidemic today is actually Europe. And that's where the epicenter, that's like the biggest hotspot. But it has spread across the world so much that now you cannot just link it to one place. Africa has many growing outbreaks. South America the same, the US the same. So the entire world now is basically in seeing an increase in the number of cases, except China and parts of Southeast Asia.
I mean, looking at debunking the myths, Terry, and we're saying now here, it's one of those huge myths, and it's still being peddled around, is that people of African descent, people of black descent, would not get this virus, or that we here in the tropics would not harbor this virus. Can you open that up for us?
Yes, and this has been repeated many times in many forums, I guess, and even on social media. But as you can see, we are having people, even in Nairobi now, getting infected. So we do not have any protection. What was happening is that, and if you can look at the map, maybe you can look at planefinder.net, the traffic, or the air traffic across Africa is so low that the exposure was much lower than the rest of the world. That could be one of the reasons that protected us. That not many people are traveling out of Africa or traveling in, as compared to many other
parts of the world.
Parts of the world, especially Europe, the US, where flights are much cheaper and much more commonly used. In addition, of course, because we hadn't had any initial cases and exposure, you cannot say you're protected before you're exposed and you actually resist the infection. The scientific bit of it is that this virus binds to a certain key or receptor on your cells. What some people have analyzed is whether there's any variation in the part that this virus attaches to, and there has been none shown across races. So you are as susceptible as the next person. The only thing that may play a role are two things. One is that Africa is very young. We have about a median age of about 20, as compared to a global average of 32, 34, I think. That means in terms of severity, you're likely to have less severity because of age.
Our young population.
Explain severity.
Yes.
I say severity, explain it.
Yes. Good question. That the elderly are more likely to get more severe illness. That's what we've observed. So if you are younger and healthy, you're less likely to get into the severe form of illness. So that could play a role. But there's a downside to that I'll come to. The other thing is the temperatures. That because you're in the tropics and it tends to be warmer, droplets don't travel very far in humid environments. So they find it easier to travel in cold and
cooler
dry
climates.
cold and dry environments.
Linger better in colder climates.
Yes, that is true. But that said and done, we still have transmission like for influenza throughout the year, despite the weather. And you can see this year we've had very poor predictability of weather. The places in the north have never had any winter, and previously they were at minus 20 degrees. So we really don't know what to expect with the climate. The other thing is that despite having fewer cases in Africa, we may actually have slightly more deaths if we get too many numbers, because our health systems are more fragile, and we may not be able to save the 2 out of 10 that require hospitalization.
Okay, we're learning a lot.
We are definitely. I have a huge question, of course, coming. We have to probably take a break, but people are eating and drinking all kinds of things because, the immunity must be built up. And maybe you can share with us what is necessary and unnecessary,
what have you been
or
drinking?
What would help or what would not help.
Lemon and ginger.
I don't know. A matter of things, concoctions of things.
There's a photo here in the Standard on page... What page is this? Page 7 of the Standard, which is showing a man called Daniel Getari, a trader in Karatina, Nyeri County, extracting sugarcane juice that he mixes with ginger and honey to make a herbal concoction. Many businesses are doing badly due to the economic impact, but he's doing so well. He is selling this thing.
I like that concoction. I actually enjoy
hot
it.
Cake. Oh, you like that?
But I wouldn't.
Sugarcane, ginger, and
You
honey.
wouldn't prescribe this as treatment.
It's not a treatment. Okay. So you may, it's good. It's a nice fruit. Ginger is is it a tuber? Or
It's a tuber.
You'll respond further in this. Right here with Dr. Moses Masika, virologist from the University of Nairobi. We are talking at the coronavirus. And just before we went to the break, we were asking, what is it, these concoctions, what people are taking, which works and what doesn't work?
Well, as I was saying, it's good to have fruits. It's good to have, actually at this point, a very healthy lifestyle. Because if you are exercising, if you are taking fruits and vegetables and basically remain active, you help your body to absorb shocks, be they infections or even anxiety from other sources. But the point that I would like to correct is the positioning of these concoctions as medication or treatment is totally wrong.
As immunization.
Yeah, they do not protect you from the virus. That does not mean because you're taking ginger and lemon, you can't get infected. You can get infected. There's no problem if you take them, but you still need to take the measures that are necessary to protect yourself from infection, because these concoctions will not be your antidote.
Right.
Yes.
We have a lot of washing hands. I think people have not washed their hands the way in which we see it happening now. People are washing their hands easily 20 times a day, hand sanitizer, this, that, the other thing.
Yes.
Could you explain to us what kind of protection is set up with the washing of hands and the sanitizer that people are going crazy about now?
All right. So I think I can start with the sanitizer so that I don't forget. The best way to clean your hands is to wash with water and soap. Any kind of soap will work. And if you do not have your water and soap, then a sanitizer comes in as a second option. The reason I say that is that many times you may have visible dirt on your hands, or you may have grease on your hands. Then a sanitizer will not work in that instance. So for that reason, you need water and soap as your primary solution. But where water and soap is not available, the sanitizer comes in as an option. So we shouldn't again tout hand sanitizers as another antidote, as people seem to believe. That if you don't have a sanitizer right now, you're dead. That's totally wrong. Now, the reason we encourage people to wash their hands and also wash our hands is because of the transmission paths for this virus. The main transmission route is that if I'm infected with COVID-19 and I cough or sneeze, those droplets could land on somebody's eyes or nose or mouth. And if that happens, then there's a risk this person could get infected. The other option is that those droplets could land on a table or on a surface that this person will touch. Once they touch, the next part, and if you observe, most people touch their face 20 to 30 times in an hour. They touch their mouth, they touch their nose, they touch their eyes with the contaminated hands. They transfer the virus directly to them. So if you keep cleaning your hands, then you avoid this kind of transfer of germs to your face. And it's good because we avoid many infections from washing hands. In fact, in West Africa, after the Ebola outbreak, they noticed that washing hands even controlled other outbreaks like cholera and other things, which is good. Yes.
So the public health issues.
So we should have been doing this for a long time. It's just that now we have a good motivator to do it.
Is it only when someone coughs that they are able to transmit this?
Currently, yes. If
so the people who talk close to you and
some people could release enough droplets, and that's why we are saying if somebody is infected or is showing symptoms, stay away from them as far as 2 meters, if you can.
So a meter distance.
A meter to 2 meters. So that if some people, as you talk, you actually throw out some droplets, and these are quite small. They actually 5 micrometers is like 1,000 times smaller than the tip of a pen. So they are very small droplets that you do not see. And if you somebody is speaking, you can actually get those droplets. And that's why we say social distancing. Keep away from crowds, keep away from people who are showing symptoms, so that you do not get infected. There are diseases like measles, which are much more infectious, that even by breathing out, I could aerosolize some viruses to you. But this hasn't been proven to be transmitted like that.
Okay.
Maybe at least for now.
Then there are those that say that sharing the same air with somebody who's infected. For example, you're in the plane.
Yes.
The pressurized cabin. You're all breathing the same air. So one person could infect the entire plane.
For planes, it's slightly different. That for most people at risk are the people sitting a few rows to the side, to the back, and to the front, because that's where the droplets can reach. But for the air, because it's filtered, it may not be very conducive for transmitting these viruses. And that's why you see most people are able, they don't necessarily infect everybody in the airplane, but a few people seated next to them because of the filtration systems.
Okay. Do viruses have a cure, Dr.
A few do, but most do not.
Okay. And could you go into a little bit more detail about this? Because this is the thing that we believe that, there's still the belief, and like we say, we're debunking the myths that a virus can be cured. There can be a cure, and then what exactly does the vaccine then do?
You're right. So there's a difference between cure and treatment in this sense. That for most viruses, we do not have any specific drugs that fight them. So we offer supportive care. So if you have a fever, we treat your fever. If you have pain, we treat your pain. If you can't eat, we find a way to feed you. If you are having difficulty in breathing, like it could happen with COVID-19, we give you oxygen or we give you a ventilator. So these are the supportive care that we often do. For a few other viruses we can treat, like HIV. We know if we treat HIV, you are able to control the infection so that you actually live a normal life. For one or two, you may be able to clear the infection, like hepatitis C. It's possible to clear the infection with drugs, but that is a rare occasion. So most viruses, once they get into your body, many of them will be cleared by the body itself. So your body's immune system, like when you get a cold, the body is able to deal with it, and it clears it. What we do during that period is to support you if you are really sick, to help you survive the fight, because it's quite a fight, and that's what makes you feel bad. It makes your joints ache, it makes you have a fever, it makes you feel like vomiting. So that is the body fighting the virus. And for COVID-19, we do not have a specific treatment. Specific meaning a definitive drug that you can say this cures or treats COVID-19. The main thing we are doing is supporting. There are few experimental drugs, actually quite a number now, that people have theorized will help, and have actually tried to use them in different patients. But before you can say this drug cures this condition, there is a threshold of evidence that has to be met, and none of them has met this threshold yet.
Doctor, you use the word cleared.
Yes.
Am I to take it that the word cleared here means cured?
Yes. So, but that's very rare, and I gave one example of hepatitis.
Hepatitis C, yes, that you did. Now, there has been mention that in as much as children are in danger and they're likely to get infected,
Yes.
that they are less likely to die than the elderly.
Very true.
Okay? Why?
What we've seen in the past is that children are as much as predisposed as adults, and they do get the same symptoms and the same manifestations, the same presentation as we see in adults. But we are seeing that the elderly people, usually above 70, but in some instances much more older, and also with the underlying conditions. You've had heart disease for a long time, you've had lung disease for a long time. These tend to predispose the elderly, because if your lungs are in trouble, this virus hits your lungs. You are in double trouble. The heart and the lungs are closely related, because the work of the lungs is to bring oxygen, the work of the heart is to distribute it. So if one of the two is not working, it stresses the other. And that means that for people with these chronic conditions, they're at a greater risk of getting severe disease. And we've seen most deaths in people who are much older as compared to people who are much younger. That doesn't mean that children are not to be protected again. They can get infected. They may require hospitalization. So we also need to protect them.
So no cure, no treatment.
Well, treatment is available, but the treatment is supportive. That means if you require supportive care, you can be treated and it helps. It's not like totally hopeless. And it's also good to note that only 20 out of 100 people will require treatment. The rest may be in hospital for isolation purposes, but they may not require treatment. Only 20 out of 100 will require treatment. And out of that, only maybe 3 to 5, depending on where you are, might succumb to the infection.
So 20 out of 80, how do you determine
20 out of 100.
20 out of 100. How do you determine the 20?
It's a percentage.
How do I know I'm in the safe 80?
How you present. So if you are having a cough, tiredness, headaches, no difficulties in breathing, so far you should be okay. When you begin to develop difficulties in breathing, then you should
That's when
go
it becomes
to
an
hospital.
issue.
And you have the other conditions constant.
Yeah, if you are much older and you have underlying conditions, then your threshold for going to the hospital must be much lower.
So is it possible that, people could sit at home with these symptoms and then with the treatment that you would use, for flu and things like that, you would actually recover?
Yes.
So we think isolating people is for the purposes of isolation, that they don't spread it to anyone else.
Yes.
But you could actually come out of this thing all right?
True. Yeah, so actually if we got too many cases, we got thousands of cases and got for over a very short time, we have not enough beds, for instance, to admit all these people. So it may be possible to change the advice if we have too many cases and say, if you're showing mild symptoms, stay home.
Stay at home.
And if
Isolate
you
yourself.
have to begin showing difficulties in breathing, come to hospital.
Okay.
And that has happened in certain parts of Europe where they are dealing with too many cases. So it's only, as I said, the 20%, the 20 in 100 that will actually require supportive care in the hospital. The rest, we need to isolate them so they don't transmit to others. So that's why currently they are going to hospital, because we also need to track their contacts. We need to track the people they may have interacted with to ensure we curb or contain the situation. But if it blew out of proportion, we could review that.
We'll have to review.
Yeah.
We'll come back and have a conversation. I'll take you to the UK, where the debate has been there that let everybody get infected. Let's set out the second wave. I want you to explain what the second wave is. Tell me whether once you get infected, does it mean that you cannot get infected again and all that. This is a Situation Room. It's Kenya's biggest conversation. We have Dr. Moses Masika. He's a virologist from the University of Nairobi. He understands viruses. So it's viruses, not viri.
Well,
Right.
what
Radius radii.
Wow.
Virus.
Virus.
would you like to call it?
viruses. Viri. No.
Whatever floats your boat, Eric.
Okay, this one does. Viruses works well because the virologist says so. We'll open up the phone line shortly, 0719-012-600. So, Dr. The UK government has done what many people have said is flip-flopping on this issue, on how to tackle the spread of the virus in the United Kingdom. First of all, the government saying we'd like everybody to get it, because once everybody gets it, then we'll be able to sort out our second wave. And it means that once you get it, then you cannot get it again. Is it true or is it not true?
I would say it's a very risky stretch of logic. I would explain this with measles. When people are immunized against measles, you may find that, let's say I'm the only one in this room who is not immunized.
Yep.
I get the measles. If you guys are already immunized, it means I cannot infect anyone else.
Right.
That is herd immunity. If the population, many people are immunized, then it means it takes you much longer if you're infected to come into contact with somebody who is not immunized. That means it is easy to control the infection. Now, in the case of COVID-19, you are dealing with a new virus that no one is immune to. So you are saying, in essence, everybody needs to be infected.
Yes.
If this happens like it has in very quick succession, that you have thousands of cases coming up, that will overwhelm your system, regardless of your wealth. You will be overwhelmed. And in that case, you have numerous deaths because this is an elderly population. You will not have enough ICU beds to support all of them. So it's really risking quite a bit. If you are using a vaccine to induce the herd immunity, then you would be okay. But we do not have a vaccine. And for that reason, I think the UK would be taking a very big risk if they don't take the containment measures that other countries are taking.
We saw that out of the same report from the UK, there was the input of the fact that some viruses over time disappeared from, the human population. That, people were infected and after some time you never heard of that virus again.
Yes.
Does that make sense in this case, whereby they were hoping such a thing would happen? That everybody infected, and then even if they were to be reinfected, it would not come back with as much veracity as it did the first time. Does that make any sense?
It does, in the sense that we were totally naive to this infection. Now quite a number of people in the world have been exposed. That means there's now some partial immunity. Unfortunately for coronaviruses, immunity does not last long.
Okay.
For measles, the immunity is lifelong. For coronaviruses and with common colds we've seen, immunity lasts for a short time. It could be months, it could be years. We do not know how long immunity to the COVID-19 will last because we've not had it for long. We are now studying the people who have recovered to see how long they keep the antibodies or the immunity. The problem with that is then if you have a few people infected and the infection dies out, it means then no one is there to infect others. But the extent that this virus has spread is such that there are so many people infected across the world that it's likely to linger much longer, and it may come back and infect others if the immunity wanes. And for that reason, although the second wave may be weaker, it could still become a significant problem like we've seen with influenza, that every year we have to keep dealing with it because of the widespread nature of the infection. So it's much easier to eliminate a disease before it spreads too much. This has spread to such an extent that it may now become a bit last longer, even at low levels in the population,
Yeah.
because there'll always be something with the infection spreading to others, even though the cases reduce, because others now have some partial immunity. Yeah, so a lot could happen. We could see a resurge, we could see it dying. There's a lot that we do not know yet.
There are
with
very
this
many
virus.
unknowns.
Yes.
Is it possible to assume, therefore, that even with COVID-19, that there may exist more than one strain of it?
That is possible in the sense that, in fact, now we are comparing the genomes from across the world to see how variable they are. And because there are two types of viruses, DNA and RNA. RNA viruses are like HIV, that changes a lot. So because this is an RNA virus, we expect that it will keep changing. The question is, does the mutation give it any benefit? Benefit could be, is it more infectious?
Yep.
Can it survive in hotter areas? Can it cause more infection? Or does it make it dull? Does it make it less fit? Does it make it unable? And usually mutations that make you less fit will not live long. It is the mutations that give you extra powers that survive. And it's possible this can happen with any virus.
Yep.
It's possible, especially when you're infecting many people. So we're observing the virus by looking at the genomes to see what changes it has and what that confers. I'll give you a good example. You remember Zika? In
The Zika
Brazil.
virus, yes.
Zika had been around for years, infecting very few people.
Yeah.
Very few people ever had signs of that. You remember the problem it was causing in babies?
Yeah, the
Microcephaly,
flattened, rounded
small
heads. Yeah.
until it crossed to Brazil, had a single mutation that made it infect cells in the brain very easily. And that caused a big problem. So a single mutation could mean a lot. We keep observing the virus for such.
Yeah.
So,
Talk about incubation. Sorry, City.
no, it's all right.
So this thing lands into your body.
Yes.
This incubation thing. Explain the incubation and the 14 days. Is it 14 days? It's 7 days? It's 21 days? Have we found out now how long it takes?
Yeah. Now, most viruses have the period between infection, and most infections between infection and show the time that the person shows symptoms. For this virus, it could be as short as 2 days. It could be as long as 14 days, sometimes longer. But on average, it's 5 days. So we are seeing that if I get infected today, I could start showing symptoms in 2 days, or I could start showing symptoms in 14 days. But most people will show symptoms within 5 days. That means that you now start to cough, start having headaches, start having
Joint
tiredness
aches.
and all that. That is incubation. Now, during this period of incubation, a lot is happening. The virus is multiplying in the body. The body is trying to form a defense. And it's actually the defense that begins to show symptoms, because as the body tries to defend you from the virus, it kills the infected cells. And it produces chemicals in the body that make you feel tired, make you lose appetite, make your head ache and all that. And that is, so the incubation is really variable depending on how quickly you mount an immune response. Yes.
Let's go to the phone lines before you go to the next question. Okech is calling in from Kisumu. Good morning, Okech.
Good morning, Spice FM.
Good morning.
I had a question. There are two questions, but I may narrow down to one.
Yes.
Now, the first one is that, is there a possibility that some of these viruses are deliberately cultured and spread out, so that people are infected? Or even if it's not the case with corona, are there known instances where a virus was made deliberately by man and sent out?
Well,
My second question is that why is it that some of these animals, which have existed since antiquity, we've known them, we've been with them, it's only in these recent times that they come up with these infections? Yes, we've interacted with them, we've known them, but these diseases come up only in these recent times.
Okay, Dr. Ari.
those are two very good questions. And what did he say his name is?
Okech.
Okech, yes. Thanks, Okech. One is bioterrorism, really speaking. As virologists and as scientists, we're always concerned about bioterrorism. And whatever we do is regulated to ensure that we do not get into the realm of making bioweapons from viruses.
Which would be made by the same virologists.
Well, not necessarily, but you
Okay.
need a lot of knowledge, maybe on virology to make. So anything that is useful, for your cause. So we know that theoretically it's possible. and we take precautions to make sure it doesn't happen. There is no evidence that the current virus was a bioweapon, and we say that because you're looking at how it is related to existing viruses, and you can relate, again, using the genomes and track where it started and how it crossed over to humans, and see that this is actually the natural evolution of a virus from his next question, which was how then animals
where is it becoming more rampant?
Yes. And I would like to introduce a concept we call One Health. That for us to secure the health of humans, we need to study the health of animals and the health of, the environment. And actually, this is work I do. I study mosquitoes, I study bats, I study rats, I study
pangolins.
humans. Yes. We even in Kenya. So we actually trap them and see what they're carrying. The reason that we could be seeing a lot of emergence of viruses, and this is not the first time, emergence of viruses has been there from a long time, including dengue thousands of years ago. We know dengue today as a human pathogen, but it was an animal pathogen. And all along we've had many other infections that come from animals. Zika, chikungunya, we can name a million, not a million, but many of them. So, and we are seeing an increase in this because of different reasons. One is that we are much more closer to animals now. We relate to them as pets, for food, for business, for recreation, and many other reasons. And we're also displacing them. So when you displace animals, two things happen. One, they will move to another place where there are other animals. And they can infect those animals with new diseases. And that means there will be an outbreak in the animal kingdom that can spill over to humans. You also, by displacing them, interact with them more closely. There are cities now that have bats roosting in public parks. There are places in Nairobi where you will find bats. So because of these closer interactions, it means you are more prone to getting whatever viruses these animals are carrying. Initially, the virus will not cause much because it is adapted to the animal. But with recurrent exposure, the virus eventually mutates, and the virus that is suitable for you emerges and now starts to transmit between humans. There's also a lot of trafficking of animals, a lot of illegal trafficking, which means we are more predisposed to, again, these diseases. And then because of travel, something that emerges from one area spreads across the world very easily. If you were in Kericho 100 years ago and you got cholera from whatever source, would you be able to bring it to Nairobi?
It would be more difficult than
you
it
would
is
probably
today.
die before you get to Nairobi. Right now, you can get a bag in Nairobi and take it to Tasmania or wherever in a day. And that makes it so much easier.
Because of the evolution of things like infrastructure and transport.
So business, and many people now able to travel across the globe in a very short period. So there are many reasons that this happens. And because our interactions with animals are closer, we are able to see these viruses emerging. And also the fact that we can detect them. Because previously there may have been crossovers that we did not detect and they die out on their own.
Is it possible for somebody to contract COVID-19,
Yes.
not show symptoms,
Yes.
and get healed without ever displaying any symptoms?
I would like to use the word recovery because healing
recovery,
is
recover.
a realm that I may not be an expert on.
Right.
So it is possible. Although there were studies that came from China that show that most people were actually showing some symptoms. That most people are not the asymptomatic, not the ones not showing symptoms. So it is possible also to get an illness, any viral illness, and not show symptoms and recover. Because then if you're not showing any symptoms, your body will clear it. What we are not very sure of is the role the people who are not showing symptoms are playing in transmitting to others, because that is our biggest worry. If somebody is not showing symptoms, she could be looking very healthy, and if she has an infection that is ongoing and is she able to infect us? That's the question. So that is something that has been a bit controversial, but
So it hasn't been established for sure yet.
For sure, we know it is possible,
Oh.
but what we are suspecting is that the people who are driving the infection are the ones showing symptoms, because when you cough and sneeze, you're more likely to soil the environment. It's possible that the asymptomatic people are also able to infect others, but the role, how many people they're able to infect is not clear.
I want to borrow from HIV.
Yes.
Okay. When we say we are testing, what are we testing? What is it that indicates and shows that somebody has the virus?
Yes. Now, currently, as I said, the genome of a virus, it's a fingerprint. The current tests are called PCR in short. They detect part of the genome and the accuracy is quite high. So we test by detecting a part of the viral genome. And when we find it, you can confirm that you found it by different ways. Then you say this person has the virus. In between that process, we built in quality controls to ensure that you are testing the right sample, you do not contaminate it, and the results that you got are valid. But the basic point is you're testing for the genome of the virus. For HIV, we also test for the antibodies. The antibodies that people develop as a defense to HIV. And somebody was actually the other day in trouble for selling an antibody kit for COVID-19.
Whoa.
Yeah, the reason being we have not validated it because before you use any test locally, it has to be validated, and we've not had enough samples or enough people with the infection to validate that kit. So maybe if we get many people infected eventually, we might consider going for antibodies as a screening test. But we have to show that the test works in our population before you can use it.
So why I brought this in,
Yes.
the Nation today reported that doctors in India
Yes.
were successful in treating it with combination drugs. And these drugs mentioned here
Yes.
are antiretrovirals.
Yes.
Okay, they mentioned lopinavir, ritonavir, oseltamivir,
Yes.
and then they used clofenomine.
Okay.
Okay, so malaria medication with antiretrovirals,
Yes.
and they said there is success.
Yes.
Now, because
How do they define success?
let me just read it.
Yes.
India is successful in treating it.
Treating.
No, there's no cure. Just treating it.
Yeah, that's a very that has not just been in India. In fact, China has released guidelines on what drugs to use. And what I would like to say is this. It is easy to use drugs that are already shown to be safe. We call it reappropriation as an experimental drug. So the threshold is much lower. You can experiment with it and see. It's much harder if the product is new and no one has ever taken it. And what we need to do now is structure these treatments in such a way, we call clinical trials, in such a way that you compare those who you gave the drug, those who did not give the drug, and look at the outcomes. So what everyone has been proposing makes sense. We have anti-HIV drugs that block a certain structure that is also found to a structure, similar to a structure found in this virus. And so right now, it's not harmful to use these experimental drugs. Even in Kenya, we could use them. But we cannot say for sure they are treatment because we do not have the evidence. So I would say chloroquine, lopinavir, you pronounce them quite well. We should give you some papers to
He does this
start
for a
treating
living.
COVID.
This is
Yes. I think I had Latif trying to pronounce it earlier.
Lopinavir.
Didn't work too well. Didn't work too well.
That's very, very.
So the drugs are safe to use in the sense that they've been tested in humans. And that is what makes it easier to experiment with them. But we do not have enough evidence to say that, yes, this is the treatment. And that's why you see they're using so many things. If we were sure what is working, we'd probably just use one or two and we are good to go. So it is okay, and it's been used in China, it's been used in many other parts of the world. We will continue to test them, but we are building a threshold of evidence to see if they actually work or not.
Oh no.
But it's true, Daktari, that why they use a combination therapy,
Yes.
because each of those drugs does something specific.
Yes, but there could also be a non-drug interactions, which we
Yes.
avoid for drugs, combinations
Yes.
we haven't used.
Or we haven't tested
Yes.
in human beings.
Yes. So there's a biological explanation why chloroquine works. There's a biological explanation why lopinavir could work, why remdesivir or whatever other drug could work. But there's not enough evidence to say for sure this is it.
This is the
And
combination.
it's okay to test now because the drugs are safe. We know they are safe from previous studies. So we will keep building this evidence. And once there's enough people compared to those who are treated with the drugs and those who are not, we can say, yes, this is the guy that works.
I want to ask about about vaccinations when it comes to herd immunity, like you had mentioned. But I know we want to go to a break and come back, and we can look at the vaccines. We're looking at testing coming out of Germany, coming out of the UK and the US. Everybody now looking for a vaccine, and they're saying they're coming very close to a vaccine, and then asking ourselves, is it okay that 3 different areas looking for one, and are we able to combine all these efforts?
And even skip the trial stages.
So you'd like us to talk about that now or after the break?
Just a short break, and then we come back and you'll respond to this, as well as take a question from caller 0719-012-600. Alex is calling in from Nakuru. Good morning, Alex.
Good morning.
Good morning.
I wanted to ask a question.
Yes, go ahead.
Yesterday, press briefing by the CS, I think he implied that people without symptoms are being released from quarantine. Are we testing them, or are we releasing them on basis of symptoms manifestation? Because we understand from China, what I've read on the news, is that there are some cases where the patients are asymptomatic. If we release them without testing, does it pose a risk to the general population? Should we stick to 21-day quarantine or 14-day quarantine also?
Okay. Dr.
Yeah.
Yes, thank you for that question. What we've seen that with the government do is that they tracked those who had been in contact with a few cases that we've had. They put them up at Mbagathi and they tested them, and those who were negative were released.
Yep.
So it was not just because they were symptomatic, it's because they were also tested and they were negative on the test. Yeah. But it's true that at some point, if we had many cases, we might have to tell people who are not showing symptoms to remain at home and quarantine.
To ease pressure on the
quarantine
facilities
themselves. But right now, everybody who suspects to have been exposed and meets the case definition will be at least seen at a facility and tested to make sure we are keeping track of the outbreak.
Okay. Talk about the vaccines now.
Yes. Now, we have had several reports of vaccines. I think yesterday or the day before, the first clinical trial of a vaccine started in the US. That's good news. But the bad news is this. The process of making a vaccine is not short, and there are no shortcuts really. You can expedite it, but you need to go through all the steps. That if I asked whether we can skip clinical trials, we wouldn't.
You can't.
It would be a big gamble that we would not pass. And the reason I'm saying this, it may be easier, not easy, to develop a candidate vaccine, meaning you have something that you think will be a vaccine. And what happens is that you test it in the lab, show that it has potential. The next step is to test it in animals to show that it's safe and also that it could elicit immunity. After that, we need to go into several stages of clinical trials where you start with a few people, maybe 20 or so, to see that it is safe. You inject them. You've already established that it's likely to be safe, but you inject these people and follow them up for months at least to confirm that they are okay. You give them 1 or 2 or 3 doses, depending on what you think is enough for immunity, and then look at them very thoroughly. You take bloods frequently. You take the blood frequently. You look at their urine. You look at the different presentation to ensure that they are safe. This takes months at the very least. The next stage after that is to pick another maybe 100, 200 people, 300 people from different places. Again, the same process. This time round, you're not only looking at safety, but you want to see does the vaccine bring up the immune response that you expect. If you pass the second stage, you go to a third stage, which is now testing that the vaccine actually works by giving the people who are at risk. This goes to thousands of people. And you want to see, does it actually protect them from COVID-19? So for this, each of these clinical trials will take on average 2 to 3 years. The permits can take up to a year in some places. So you can shorten the period for the permits. But the period
2 to 3 years, the trials cannot be shortened.
So even if we were to move very fast, we would not have a vaccine, at least not in 2 years or so. So it may come in several months, but it's likely to take much longer. It's easier to develop to reappropriate a drug that is already safe than to get a vaccine into the market.
What's the preferable course here? Looking at an appropriate treatment or a vaccine? You talked about herd immunity before.
Yes.
What is the preferred?
Vaccines are best,
right.
But given the circumstances that we are many months away from a vaccine, we have to use many approaches, and that's why we are talking about hygiene, social distancing, and if we actually prove that some medications can work, it may be possible to give people who have been exposed before they develop symptoms.
Okay. With this story that we saw coming out, I mean, what should we be advising people to do? You have the symptoms, take yourself to hospital. We heard also from the Ministry of Health yesterday that they said, you have these, call the hotline and we will come for you.
Yes.
This is what they said yesterday.
Yes.
We will come for you,
Yes.
regardless of where you are. But then we have the panic that arises. I feel a certain way. I'm in a group of people. I feel like I need to get into a taxi, take myself to
Now.
hospital. Practically,
Yes.
I need to go now.
Or the hotline is not going through.
Oh, yeah. What should people actually do?
Now, the reason you are advised not to go to hospital is because you do not want to expose the people at the hospital, both the healthcare worker and the patients who are vulnerable. These patients are already in a weakened state.
Yeah.
So they are more likely to get infected. And so the government is taking it upon itself to come to you, assuming that where you are at home is much safer for you than when interacting with the public. Because somebody could be, say, in Kayole, ask them to come to Mbagathi. They are going to board a matatu, maybe 2.
Yeah.
How many people are exposed in
Yeah.
that process?
Yes.
And that's why the government is encouraging people to call the hotline. I've tried it on both of my numbers. It works.
At all times of the day?
And I think even night, because I've not tried it late night, but I think it works. So the idea is to provide people with information. Not like it's 719 now. Previously, there were numbers that were a bit questionable.
Yes.
800.
That even I had a bad experience with. But the current one, 719, there has been a lot of investment and stakeholder engagement.
It works.
That makes it work better.
But what about this matter that we're discussing? Does it work? Healthcare workers coming to you?
It works because we will only send a few healthcare workers to you, and they will come and take...
What I mean is,
Yes.
has it worked? We're discussing the plan, the intention.
Yes, it works because they've actually sent to places. And
We have evidence that they have actually sent.
Yes. And they send with their specific
They've sent
vehicles
ambulances
with
to go.
with the, what are they called, the right protection.
The N95.
The spacesuit.
Well, there is a lot more to this. I wouldn't call it a
we were told there were
spacesuit,
aprons
but
yesterday.
Yes.
Moses, yesterday we were told it was aprons.
Yes. So I'm saying they're not quite a spacesuit, but that would be quite expensive to do. And the idea is to, if for example you're able to stay in your house and interact with fewest people possible.
Yeah.
They come to you and get the
We're
sample.
managing this.
And then they tell you it's negative, you can go on with your life. Or they tell you you're showing symptoms, now we need to put you in isolation. And most people in Kenya with these symptoms are just having a common cold. It's just that because of anxiety, they feel they're infected.
Yeah.
So if you say everybody should come, everybody with a common cold will come to the hospital. The hospital will shut down.
I have a quick question, and I know Eric
purpose.
wants to bite me, but quick one about children playing, because children have closed, schools have closed, but
Yes.
children are in the estates, apartment buildings, whatever, all playing outside.
Yes.
What would you, and then we have parents saying, take your children inside. People are panicking. What do we do? What would be the advice for that in terms of how it could spread amongst children?
Well, by mingling, yes, it's easy to spread, and children tend to be very close with each other. So it's very easy to spread among children, and then of course it comes to the parents, because the parents will then kiss and hug their kids. So I think we now need to be very innovative on how we engage our children indoors, and if they're interacting outside, then in very small groups that don't
Highly
increase.
contained.
Yes. So it's a time that we may need to make social adjustments, and this includes for our kids, meaning that in different circumstances, of course, you need to, depending on where you are, adapt to the situation and see how to engage. I've seen one of the schools in Nairobi actually send their parents a schedule of now to keep their kids busy. Which is interesting. So
A proposed
we
timetable.
need to be innovative. And depending on the situation,
Right.
engage our kids safely but creatively, because kids have a lot of energy and they need to. If they don't expend it, then there's going to be a lot of sadness.
Dr. Masika, finally,
Yes.
are you satisfied with the measures that the government has taken so far? Do you think there is more that we could have done that we are not doing now?
There is still some more we could do, but so far I'm happy with the recommendations they've made. I think social distancing and hygiene, that in the areas that we need to do more, and this is not a role of the government, only is information. And you can imagine, even as a media, we are struggling with the social media and other means of non-mainstream means of passing information that has overwhelmed many systems. So we need to deal with that. The other bit that we need to look at is healthcare itself. Across the country, are we sure that each facility would be able to handle a case? without causing a spread.
Yeah.
Healthcare workers in many parts of the country are still not feeling confident about this. We need to address that. And also, we probably need to take the message to the communities, because there are things I've said so many times and I still get the same questions. It means I'm not communicating to many people.
Yeah.
We need to take the message to more effective messengers, maybe community health workers or people who are in constant contact with the communities.
And this should be happening now.
Yes.
Not creating the messages so they can go in at the end of next week.
No.
Asante sana for joining us.
Eric, the issue of the kits, how many people does one kit test?
Well, it depends on the kit itself. There are different kits. On average, one kit could test 100, but because sometimes you need to repeat to confirm and do all this, it's really dependent on the situation. So you may need many hundreds of kits currently to be available. And I think there may be a shortage across the globe, but currently we have enough because our cases have been limited. If we have thousands, that's what I was saying, we may need to innovate and go into antibody screening first so that we don't waste the kits on those that are negative, but for confirmation.
Dr. thank you very much for joining us today. We'll invite you again. Of course, we know that this is going to be a prolonged period. There'll be more and more questions, more and more myths being spread around, and we'll be calling you to come in and shed more light on this.
Thank you for the opportunity to share this and for the platform. I'm glad to be in the Situation Room and to meet all of you.
The platform is open.
Thank you very much.
And we are delighted to have you.
Thank you.
Asante sana.